All right, today we're going to look at the last unit, or the last module part of Unit 2. We're going to be looking at nets and 2D representations of three-dimensional figures. All right, so a net is a diagram of the surfaces of a three-dimensional figure that can be folded to form the three-dimensional figure. So if you imagine, you could cut the shape of these out, fold them along the lines, and they would make a three-dimensional figure. So to identify a three-dimensional figure from a net, you look at the number of faces and the shape of each face. So for example 1, we're going to just name the three-dimensional figure that can be made from the given net. Example 1A here, these 6 green squares. We could fold those 6 squares together and that would equal up a cube. Right, they're all the same size, so imagine like a box, right? B, if you imagine folding that up, it would create a cone. If you ever unfolded one of those paper drinking cups that you get out of the sleeve beside a Gatorade jug or something like that, you know that it unfolds into a semicircle, and that circle on the end there would be like the top of that. C is a prism, or a pyramid. It's going to fold to a pyramid. The 3 triangles on the outside fold up to a point at the top. And specifically, that's a triangular pyramid because the base of the pyramid is a triangle itself. All right, so that's a triangular pyramid. And then D, that is going to form a cylinder. All right. So this solid that is represented by the net here is a prism because we know it doesn't go to a point, so it's not a pyramid, and obviously there's no circles, so it's not a cone or a cylinder. So it's got to be a prism, and we know that the 2 congruent bases that are opposite each other are going to be triangles. So this is a triangular prism. All right, so since it's a triangular prism, we're going to follow the prism formula to find the surface area. So the triangular prism, or the prism surface area formula is the perimeter of the base times the height plus 2 times the area of the base. So the perimeter of the base is we just add up the 3 sides of the triangle. 16 plus 10 plus 10. So 16 plus 10 plus 10. And that gives us our perimeter. The height of the prism, in other words, how far apart are the 2 bases? Well, they're going to be 20 inches apart. So that's where the 20 goes. Now we have the 2 times the area of the base. Now to find the area of the base, we need to find the height of the triangle. So to find the height of the triangle, what we're going to do is a little figuring. You can imagine I can cut this triangle in half and figure out the height that way. Well, if I cut it in half, that means that these sides are congruent, and that means this is 8 and this is 8. So I have a triangle with one side 8. The other side I don't know. I'm going to call that H. And then the third side is the hypotenuse is 10. So I can actually use Pythagorean's theorem to solve for this. 8 squared is 64. 10 squared is 100. So I can subtract 64 off of both sides to get h squared is equal to 36. And take the square root of both sides to get that h is 6. So this triangle has a height of 6 inches. All right. So now I can find the area of the triangle. Area of the triangle is base times height over 2. So that's going to be 6 times 16 over 2. So we can go ahead and do some simplifying. 16 plus 10 is 36. And then the 2's cancel out, so I'm just left with the 6 times the 16. So that's going to be 128. Wait, I think, nope, sorry. 96. Sorry about that. Six times 16 is 96. So now I just need to do the 36 times 20. It's 720 plus 96. And we get 816 square inches. Okay, the next solid here is going to be a pyramid, and it looks like it's going to be a square pyramid. So I can tell that because the bases have the same dimensions, 8 by 8. So pyramid surface area formula, again, square pyramid. Go ahead and write that down just in case I forget. Pyramid surface area formula is going to be the area of the base plus 1/2 perimeter of the base times the slant height. Okay, so the area of the base is going to be 8 squared. Since it's a square, I can just take the side squared. And the perimeter of the base is going to be 4 times 8. And then the slant height, well, we're going to have to figure that one out. So, again, we're going to do the same method. This is going to be 4, that's going to be 4. So, we could do 4 squared plus h squared. Actually, let's make that L squared, since it's going to be slant height. L squared equals 10 squared. 4 squared is 16. And 10 squared is 100. Subtract 16 off of both sides. So we get L squared is equal to 84. So then I take the square root of 84. And let's see, that simplifies down to 84 simplifies down to 2 square root of 21. Okay. So multiply that by 2 square root of 21. So 8 squared is 64. Half of 4 is 2. 8 times 2 is 16. So 2 times 16 is 32. And we're going to leave it just like that. That's as precise as I can get. I could approximate that. Square root of 21 is 4.58 thereabout. Multiply that by 32. And then add 64 to that. And we get approximately 210.64 square centimeters. But 64 plus 32 times the square root of 21. If you think about it, square root of 21 is going to be somewhere between 4 and 5. 32 times that decimal plus 64. It's going to add up to equal to 110.64. All right. The last thing that's part of this lesson is being able to draw a net. And there are going to be some questions on the test that require you to do that. Actually, there's just one. But this is asking us to draw a net for a hexagonal pyramid. To draw a pyramid, you're going to draw the base first. So put the base in the middle. And in this case, that's a hexagon. I'm never going to judge you by your art skills. The hexagon has all 6 sides congruent, and they're all 5 centimeters. Next we have a triangle coming out of each face. And so these are all going to be congruent to each other. And those are all going to be 13 centimeters. And that's, even though that is a horrible drawing, that works as a net. You just draw the base first, and then you're going to draw triangles. It's always triangles for a pyramid. You're always going to draw triangles off of the base, off of the face, each side of the base. So that is it for nets and drawing two-dimensional figures, or representing three-dimensional figures with two-dimensional figures. All right, if you have any questions, please just shoot me an email or a message on Canvas. Have a great day.